Hello, I'm Ray Joshua Gecka,
And this is Natalie Greer.
and today we're going to be giving a quick introduction to pH.
So, everyone's lives can be enhanced by a pet, and those who have one to join their family have the opportunity to experience the unconditional love and meaningful relationship a pet brings. Taking care of your pet is a huge responsibility in the fact that they cannot care for themselves and solely rely on us to do our research and remember to constantly think of them. So, for the sake of this experiment, let's talk about fish. Some would say that fish are a perfect beginner pet and they require relatively little to no maintenance. However, that doesn't mean that as long as you feed them, they'll be okay. The most obscure responsibility that fish owners have to worry about is the pH levels of the water that the fish resides in. So, why does the pH of the water that you put your fish in matter? In order to figure that out, we must ask ourselves some questions such as, what is pH? What is the differences between an acid and a base? What are the properties of acids and bases? And what is a neutralization reaction? What happens when two things with varying pH come into contact with each other? The answers to these questions should help us understand why it's so important to maintain the pH levels of your fish tank.
So, what is pH? Well, when it comes to pH, we need to know the basics, starting to what does it mean? pH is a measurement of the concentration of hydrogen ions, more specifically positive hydrogen ions, present in a substance. The pH scale itself goes from 0 to 14, where values that are closer to 0 mean that a solution is more acidic, while values closer to 14 mean that they are more basic or more alkaline. And at the bottom is a sample of the pH scale.
So here's another example of a pH scale, but it has some like everyday items in it, like Coca-Cola, wine, even blood. So as you can see, some things like acid on the very left, it's very corrosive and it's very sour in taste. Bases are farther on the right. It's usually slippery to touch and bitter to taste. Alkaline is another way to describe like what bases are.
And bases are commonly used in cleaning products such as drain cleaner and, as you can see, laundry detergent and soap. So to keep continuing on, the concentration of hydrogen ions actually scale logarithmically when going up or down the pH scale. For example, there are 10 times more hydrogen ions in a solution with a pH of 6 than a solution with a pH of 7. And if you were to go down even more to, let's say, a pH of 5, that means it would have 100 times more hydrogen ions than a solution with pH of 7, and only 10 times more than a solution with a pH of 6. And this chart on the right basically shows that relationship, where if you go to 0, it shows that basically the whole substance is just hydrogen ions.
So let's talk about the next concept, which is, acid. Acids are substances that have a pH below 7. Acids, when put in an aqueous solution, will break off and form positive hydrogen ions. There are two types of acids, which are strong and weak acids. Strong acids are acids that will dissolve in water, where all the hydrogen ions completely dissociate, which is like breaking apart. Acids release H plus ions into the water, which therefore makes it very acidic. While weak acids only partially dissociate when dissolved in water. Examples of acids are vinegar, hydrochloric acid, lime juice, and lemon juice. Next, we're going to talk about what is a base. Bases are substances that have a pH above 7. Bases release hydroxide ions into aqueous solutions.
Just like acids, there are also two types of bases, and there are strong bases, which completely dissociate in water as well, but instead of releasing H+ ions, they release hydroxide ions. And weak bases only partially dissociate. Examples of bases are baking soda, soap, and drain cleaners. So another concept that we should understand before continuing on into our experiment is, what is neutralization? Well, neutralization is when you combine an acid and a base and they react in order to form salt and water products. And usually the pH of a resulting solution of a neutralization reaction is also going to be neutral or very close to 7. A very simple example of a neutralization reaction is a H+ ion or a proton plus a hydroxide molecule. And when those two combine, they make H2O or water.
Now that we've gone over those concepts, we can talk about the experiment. So first we need to gather our materials: paper towel, several beakers, graduated cylinders, water, dish soap, which is one of our bases, apple cider vinegar, one of our acids, lime juice, another acid, gloves, goggles, lab coat, potassium hydrogen phthalate, another acid. We used a pH meter to read our levels. Baking soda is one of our bases, a scapula, and a scale.
And here is just the materials that we used during our experiment.
And on the right is a picture of our pH meter that we used.
And as you can see, that pH meter is currently reading 7.85 pH, which means that that solution that it's inside of is slightly basic. So in this video, we are testing a potassium hydrogen phthalate and baking soda reaction. And right now we're just preparing to combine the two and observe what reaction occurs. So as we combine the two, we notice that there is slight bubbling occurring, and that the solution itself turned into a milky white kind of color due to the clouds. And we can assume that because of this, that because of the lack of reaction, we can assume that potassium hydrogen phthalate might be a weak acid, because it might not have completely dissociated or completely released all of its hydrogen plus ions into its solution before being mixed.
So to start our experiment, like I said, we gathered all of our materials. Then we labeled a beaker for each substance that we're going to test. Next, we're going to use a graduated cylinder, measure at least 75 milliliters of each acid, and put them in their own respective beakers. If the substance is a solid, we're going to use a scoop and dilute it in water and record the volume. Next, we're going to find the concentration of acid for each of the acid solutions, and then measure that same amount of base and mix that with the 75 milliliter of water. Next, we're going to use the pH meter, but we need to make sure that it's calibrated first. And we will measure the pH of each substance and record the values in our data table. Once you've tested the pH of the different substances, take the baking soda and apple cider vinegar and combine them. Now write down your observations and then test the pH of the resulting solution. Lastly, we're going to repeat step 4 until you have tested a combination of 2 acids, a combination of 2 bases, and at least 1 or more acid-base combinations. Be sure to record your data and what you've observed. So here's a chart of all the data that we collected together. As you can see, when apple cider vinegar and baking soda was combined together, their